All right, let's move on to number 26. It says a stock that was selling for $42, a share was split 3-for-1. Before the split, the company had 2.6 million shares of stock outstanding. What is the post-split number of shares outstanding? So I want you to picture this like I have basically this long piece of licorice, okay? So I have one piece of licorice, but if I were to break this up into 3 even pieces, I now have 3 pieces, but it's the same length as what one piece was before. It's the same thing. It says that I get 3 for each one. So if I take the 2.6 million and I multiply it by 3, I now have 7.8 million shares of stock. All right, Miss Histrom is driving on a snow-covered road with a drag factor of 0.3. She brakes suddenly for an elk and she leaves a yaw mark with a cord of 46 long and a middle ordinate of 5 feet. What is the minimum speed she must have been going? So the first thing that you need to know is there are 2 formulas here. The first one, you are going to take the cord and square it, divide it by 8 times the middle ordinate, and then you're going to add to that the middle ordinate divided by 2. So the cord here is 46 and the middle ordinate is 5. So moving on, we get 46 squared divided by 8 times 5 plus 5 divided by 2. When I do that entire thing, I end up in the calculator with 55.4, and this is my radius. And I needed my radius to then get my speed, because the second formula is speed equals the square root of 15 times FR, where F is the drag factor and R is the radius. So plugging it in, speed equals, and let me change colors, make it easier to see, the square root of 15 times the drag factor, which was 0.3, times the radius, which was 55.4. And when all is said and done, I was going 15.8 miles per hour. All right, in 2006, the tax schedule is down below for any of those married filing jointly. And it asks for the equation that represents the taxable income interval of $61,300 but not over $123,700. So if you look, it's asking about this line right here. And so the equation portion of it is right here. And it says that it is going to be, so the tax is $8,440, I got that right there, plus 25%, and it says of the amount over $61,300. So X minus $61,300. We don't know what the income is, so we have to give it a value of X. We are then going to distribute this, and we end up with Y equals 8440 plus 0.25x minus 15,325. I'm going to go ahead and combine my like terms, and the equation ends up being 0.25x minus 6885. And that's the final equation. All right, the graph shows the supply and demand curves for the Cajun spice mix that Leroy manufactures in a home business. What will happen if he sets the price at $829? $829 is right here, and you can see as it's got a dotted line coming up, this is what will put you at equilibrium. This is the perfect price to place that at. So what if we put it at $3.99? At $3.99, the price is too low. And if you think about it, if you have some great deal, let's say you wanted a new iPhone, and for whatever reason Verizon is selling the new iPhone 7 for $100. Well, we all know that that's just not seen anywhere. They're usually closer to $400, $500, $600, $700. So if somebody offered it for $100, you'd be running in to get it as quickly as possible. And so what's going to happen is that the demand, the number of people who want it, is going to exceed the supply. Now I'm just going to throw one more in there. Let's say I placed the price at $12.10. Well, if it's there, that's like saying I'm going to charge $1,500 for the iPhone. Who's going to pay $1,500 when you can get it for $500? So in this case with $12.10, the supply exceeds the demand. People don't want to buy it from them because it's too expensive, so they have all this product left over and not enough people who want to pay that price. All right, number 30. It says here that Sonny bought a $1,000 corporate bond. It pays 6.4% interest, and she keeps the bond for 13 years. How much will she earn in interest? This is a very basic, simple interest formula. It's $1,000 at a rate of 6.4% for 13 years, and she's going to earn $832. All right, this next one is going to be one of the more confusing ones. It might be one that you want to hold for last as you're working through this. It says Nick wants a car that costs $28,970. He's going to have a down payment of $5,000, and his payments are going to be $520 for 5 years. Through research, he finds that his car is going to completely depreciate to zero in 11 years. At what point will the car's value equal the expenses? So we actually have to come up with two equations here. We have a depreciation equation and an expense equation. So let's start with the expense equation. We know that it's going to cost $520 a month for however many months we're going to pay for this, and that he put down $5,000. Now we have the depreciation equation, and in this case we've got y equals, and if the car values at $28,970, that's our value here, and then we're going to add to that the slope. So the slope we have at, when the car is 0 years old, it's going to be worth $28,970. And when the car is 11 years old, its value is going to be 0. So using our formula of y2 minus y1 over x2 minus x1, I've got x1, y1, x2, y2. So I end up here with 0 minus 28,970 all over 11 minus 0. And in all, it gives me negative 2633.64. So that is the slope. That is the amount at which the car is changing in value as each year passes. So that is now my depreciation equation. I'm going to go ahead and erase this slope stuff so that we can continue with this equation. So it's asking when they are going to be equal. So not so hard. We're just going to set the two equations equal. But hold on, there's one little problem. Right here, this value is per year, whereas this one is per month. So I have to get them both to year. I have to compare apples to apples. It's an easy fix. I just take 520 and I multiply it by 12 and I end up with 6,240. That is how much I pay every year. So this equation is now y equals 6240x plus 5,000. Now that is actually in terms of a year. We're now going to set the equations equal. I have 6240x plus 5,000 equals, and this should be a negative 2633.64x plus 28,970. Now we're going to go ahead and we are going to subtract 5,000 from both sides. And we're going to add 2633.64x to both sides. And when I do that, I end up with 3,606.36x equals 23,970. My last step is to divide both sides by the 3606.36. And I end up with 6.6 years. So a lot of stuff there. All right, number 32. Maxine works at an amusement park. She recorded the number of ice cream cones she sold each day, and she came up with a linear regression equation of y equals 9x minus 487, where x is the temperature and y are the cones sold. And it asked how many will she sell if the temperature is 89 degrees. So we simply plug in 89 for our x and we do the math. And we end up here with 314 cones are what she expects to sell on that day given the temperature of 89 degrees. All right, on the 3rd, the corporation closed at 44.67. This was a decrease from the close of day before. What percent of change is this? So we have, it's the change over yesterday or the original. Well, if it decreased, it means yesterday it was higher. So we take the 44.67 and we add the 44 cents in and we find out that yesterday the price was 45.11. So we take the change, which is the 44 cents, and divide it by 45.11, and we find that we get 0.01, which is a 1% change. And we're going to go ahead and finish the last 7 or so on the last video. Good job, everyone.